Hello, welcome. Today we're going to be looking at how to solve for the eigenvalues and vectors using the normal method, eigenvalues and vectors. If you're given a given matrix like this, 7 3 7 3 3 1, just like this. This is a 2 by 2 matrix. You can be given a 3 by 3 matrix, and you're told to find the eigenvalues and vectors of this. Number one thing you do is that you multiply the n by n matrix, identity matrix similar to this by scalar. So find an identity matrix. This is a matrix, this is an identity matrix similar to this. Only that in every identity matrix you have 1 1 in the diagonal and every other thing zeros. So if this were to be a 3 by 3 matrix, make sure you also use a 3 by 3 identity matrix. So first step is to multiply the n by n identity matrix by scalar. So this is the identity matrix and this is the scalar quantity. So you see it's multiplying it, and when it multiplies, very simple, this will give you this times this times this 0, this times this 0, this times this. So this is what you're going to get. That is the first thing you do. Second thing, subtract the identity matrix multiple from the matrix A. So this is the multiple that you've gotten. Subtract it from matrix A. This is your matrix A. You write your matrix A minus the multiple that you got from here. You write it. So 7 minus this will give you 7 minus lambda, 3 minus 0, 3, 3 minus 0, 3, minus 1 minus lambda, minus 1 minus lambda. So you've done the second step. Third step, find the determinant of the matrix and the difference. The determinant, what is the determinant of this matrix that you found? Can you see this matrix that you got from the second step? Find the determinant. And so first determinant, you know what to do. You put this one first. Then you cross and cross, you put this one, that is it. So this times cross and cross, what is left? You get this one. Minus, for the second one, you put this one, which is 3. Cross here, what is left? 3, put here. So you multiply out, you're going to be getting minus 7. If you multiply this by this, you get minus 7 minus 7 lambda plus lambda squared. This like this, minus 9. So this will simplify to lambda squared minus 6 lambda minus 16. Now that you've done this, solve for the values of lambda that satisfy the equation, that determinant, equate it to 0. So this determinant that you got here, equate it to 0 and solve. So if you do the factorization, you have lambda minus 8, lambda minus 2 equal to 0. So lambda will give you 8 and will give you 2. So these are the what? Eigenvalues. So for each of these eigenvalues, you can find the eigenvectors. How do you do it? Now, the value that you've gotten for lambda, get back to the equation, this very equation. Get back to this equation that you have here. 7 minus lambda this. Substitute those values of lambda. Since you found it, you are now using 8. So put 8 here. You have 7 minus 8 minus 1. You write the 3 here. Write this 3. Minus 7 minus 8, you have minus 9. Now create a single column matrix of x. So since this has 2 rows, it's going to have 2 rows, but it will have single column. So the value that you get for x1 and x2 will be the eigenvectors. So and equate it to 0. So you have this equation. Solve out. That's the normal way that you have to solve simultaneous equation. Solve for x and y. So once you solve for x and y, the values that you, solve for x1 and x2, the values that you get becomes your eigenvectors. So that's how you solve that. You can use simple Gaussian elimination method to find your x1 and x2. So the values that you get becomes your eigenvectors. But the value that you get from this initial step to this place becomes your eigenvalues. So that is this step. You follow this step gradually, multiply. Once you're given the matrix, check the matrix n by n matrix of 2 by 2. If it is 3 by 3, you form the 3 by 3 identity matrix, multiply by lambda. Anything you get, subtract it from the initial matrix given, then solve the determinant that is given. Equate anything you get to the determinant to 0. Solve out the factorization, get your eigenvalues. Then to find the eigenvector, substitute what you get for the eigenvalue into the initial equation that you got from this. Once you substitute, you get a given value. Form a single column matrix of x1 and x2. If it is a 3 by 3 matrix, it will be x1, x2, x3. So those values of x1, x2, x3 becomes your eigenvectors when you solve out equating to 0. So you can solve this one using Gaussian elimination method or any of the other simple methods. So that is how you find eigenvalues and eigenvectors using the normal method. If you like this, please share it so that other people can see it. Click on the subscribe button. Thank you. God bless.